Okay, welcome to lesson 3.2. In this lesson we will solve a system of equations algebraically. Specifically, we'll be using the substitution method, and the name of the method is just what we're going to be doing. We're going to be substituting into one equation a different value from the other equation. So our objectives are to find the solution to a system of equations using the substitution method. So first I want to remind you and point out that we have three different ways we can have solutions. Today we're going to be looking at this first way. We're going to be looking at finding this intersection point. In this example it's 3, 0. So I know that 3, 0 is on the red line and it's also on the blue line. Therefore, if I take 3, 0 and plug it into, for x and y, into this red equation, and simplify, I will get 6 on the left side, which equals 6 on the right side. It will balance. It will be a solution. It will also work for the blue equation. If I plug 3 in for x and 0 in for y, I will get 12 on the left side, which equals 12 on the right side. And that's how I know it's a solution. It works for both. It's the one point where the two lines intersect. It's the one point where they both have the same solution. Remember that we can also have parallel lines. Lines that have no solutions because they do not ever intersect. So points that work for the red line will not be solutions for the blue line, and vice versa. We also have equations that are the same line. Now remember, if an equation is the same line, you have two equations and they're the same line, those aren't parallel lines because they aren't sitting next to each other parallel. It's the equivalent line. It's the same line. And in this case, every single point, an infinite number of points, are solutions because the lines are the same. Okay, let's begin with our first example. So let's go and look at some background knowledge. If I tell you that x is 5, if you remember early on, I often would give you a problem where you would have x equal to something and you would want to evaluate. And that's really what we're doing. We are evaluating. We are taking what x equals and we are plugging it into the other equation and evaluating it. So x equals 5. So I will put a box around the 5 and I will make an arrow down to x because that's what x is. I'm going to substitute 5 in for x. In other words, I'm going to replace x with 5 and solve. And that's really all that substitution is. So in order to move forward from here, I would want to go ahead and rewrite this second equation. So I would have 2, but now I no longer have x. I'm replacing it with 5, and then I have 6y still equals 28. So if you look at what we accomplished, now we only have one variable in this equation. It will be easy for me to solve to get y. So first thing is to simplify what's on the same side. And 5 times 2 we know to be 10. So 5 times 2 is 10. Still writing what I have, plus 6y equals 28. Now what I'm going to do is move the 10 to the other side, so I will subtract it from both sides. Okay, and on the left side now, I only have a 6y, and on the right side, 28 minus 10 is 18. Finally, I will divide in order to remove the 6 from the y. 6 divided by 6 is 1, y is still there, and 18 divided by 6 is 3. So now I know the coordinates of where they intersect, or I know half of the coordinate. I know the 3 is there, but I don't know what x is. But if I look back up here in this equation, x is 5. So actually in this one, this is a very simple one, I know that the point of intersection of these two lines is going to be at 5, 3. Okay, so x is 5, y is 3. Let's look at that graphically, give you an image of that. So here we have the equation x equals 5, and you can see the equation at the top right here. And then our second equation was 2x plus 6y equals 28, and I've graphed that. If you'll notice where they intersect in here, right at this point, think about the coordinates of that point. The coordinates of that point are, we went over 5, and let's see, up 1, 2, 3. So the coordinates of this point, of intersection point, is in fact 5, 3. Okay, so let's move on to the second example. So now it gets a little more complicated. We don't know exactly what y equals, but we know that it equals 3x. So again, I'm going to do the same thing. And if you do this as well, it'll be a lot easier for you to solve by substitution. So I'm putting a box around that, and I am going to draw an arrow to the y, not the x, sorry, because this is what y equals. So y is 3x. Now I'm going to do the same thing as I did last time, and I'm going to write this out. So in place of y is no longer there. I'm going to substitute 3x in for y, and I get negative 32. Now I'm going to combine like terms, so 3x, and this is 1x, right? If there's nothing in front, it's like having a 1. So I end up with 4x equals negative 32. Okay, and then finally divide by 4 to separate the 4 and the x. 4 divided by 4 is 1, so I'm left with 1x equals negative 8. Okay, on this one I do know the x-coordinate. I know that the x-coordinate, and I'll write it down here, is negative 8. But what I don't know right now is the y-coordinate. But I know that y equals 3x, so all I have to do is plug in a negative 8 in for x, since I know what x equals. So let's go ahead and take this equation, draw a line out here. So I know that y is equal to 3, and I'm going to substitute, so I'm going to draw a box around this, negative 8 in for x. So I'm going to put negative 8 in for x. And then all I have to do is simplify. Negative 8 times 3 is negative 24. And now I know what y equals. Okay, so our point of intersection is negative 8, negative 24. And if we look at that graphically, we'll go back over here. We have our two equations, y equals 3x, and x plus y equals negative 32. And I'll probably need to pan in here. Let's see, what was our answer? It was negative 8, negative 24. So I know that it's actually going to intersect down here, and there it is. Okay, and so if I look at, if I look over here, negative 8, come down here to negative 24, that is that point of intersection. So you can see it visually if you graph your two lines. Okay, good. All right. One thing that I didn't go over on the last one because it was a very simple one, but I'm going to go over on this one, is you always want to check your solution. You always want to check to make sure that your solution is correct. So let's start here. Let's do a check. So the way we do a check, and this is how you know if you're right or wrong, is you just take your answer and you plug in the negative 8 for x and the negative 24 for y. So in our first equation, I have negative 24, plugging that in for y, is equal to 3 times negative 8. Negative 24 is equal to negative 24. That checks out great. If I look at my second one, let's look at our second equation. We have x plus y equals negative 32. So we would have negative 8 plus negative 24, and that should equal negative 32 if I did it correctly. Well, negative 8 and negative 24 add together to be negative 32. So that one checks out okay too. So you should always check your solution by plugging it back into your two original equations and making sure that it does in fact work. Okay, let's look at example number 3. So we get increasingly more difficult, but still not bad. So in this case now we know that y is equal to x plus 2. So again, I'm drawing a box and I'm putting an arrow to the y because that's what y is. And then I'm just going to rewrite my bottom equation, okay, as 3x plus 5 times x plus 2. Notice that I'm keeping the x plus 2 in parentheses. It's one term, and that still equals 10. So all I've done is replace the y with an x plus 2. And now I'm going to simplify. So in this simplification, I need to remember to distribute the 5 into the parentheses. So 5 times x is 5x. 5 times 2 is 10. Okay, now my parentheses are gone and I can combine like terms on the same side. So 3x and 5x will give me 8x. And now I'm going to combine my 10, so I need to move this 10 to the other side first. And on the left side, I'm left with 8x, and on the right side, 10 minus 10 is 0. Okay, finally I will divide by 8. 8 divided by 8 is 1x, and 0 divided by 8 is 0. So now I know the coordinates, or half the coordinates, of my solution. It's going to be 0, comma, something. Those are my x coordinates. So what I want to do now is I want to take this 0, and I want to plug it in for x in one of these equations. And I'm going to choose the top equation just because it's easier, because it's already solved for y. So I'm going to write y is equal to, and I'm going to replace the x with the 0 plus 2. Well, 0 plus 2 is just 2, and now I know what y is. So y is 2. So I know they intersect at 0, 2, and we can check this graphically. So we have y equals x plus 2, and I believe it was, 3y plus 5x. So in these two equations, we said that they intersect at 0, 2, and here it is, right here. So we went left and right 0, and we went up 2, and there's our intersection. So you can see it graphically as well. And remember, if we were going to do a very good job with this, what we would want to do is check our solution. So we would plug it back into our original equations. So let's do a quick check on this. Okay, so in place of y, we would put 2 in the first equation, and in place of 0, we would put in place of the x, we would put the 0, and then we would just confirm that the left side equals the right side, which it does. Okay, and then we would check our second equation. So in place of x, we can put 0, and in place of y, we would put our 2, and we need to confirm that the left side does in fact equal 10. And if you'll notice, 0 plus 10 is 10, 10 does in fact equal 10, and this checks out as well. So we saw it both graphically and algebraically that 0, 2 is the point of intersection. It is in fact our solution. Okay, just a couple more final examples. Let's try this one. So here our bottom equation is a y equals. So this is what we're going to replace y with in our top equation right here. So this time we will rewrite our top equation, and I will replace the y with the 2x plus 1. And that is still going to equal 3x minus 2. Now I will need to remember to distribute the 2 into the parentheses. 2 times 2x is going to give me 4x. 2 times 1 is 2. Now I'll need to combine like terms. So I'm going to move the 3x to combine with the 4x by subtracting. 4x minus 3x is just x. And then on the right side, I still have the negative 2 there. Okay, and then now I need to move the 2 over by subtracting 2. So on the left side, I'm left with x because 2 minus 2 is 0. But on the right side, a negative 2 plus a negative 2 gives me negative 4. Okay, so now I know what the x component is of my solution set, and that would be a negative 4. Okay, and now I just need to figure out, so I'm going to put a box around this to know that this is what I'm going to substitute. Do I want to put it in the top equation or the bottom? Again, it doesn't matter, but I'm going to choose the bottom one because it's already set up as a y equals. So it's easier to simplify. So y will equal 2, I'll replace the x with a negative 4 plus 1. And 2 times negative 4 is negative 8. Negative 8 plus 1 would give me negative 7. So now I have this solution of negative 4, negative 7. Let's go ahead and check that graphically. So negative 4, negative 7. So we want these two right here. And if I go to negative 4 and I go down here to negative 7, so I went over negative 4 Down here, that's negative 7. In fact, that's where they meet. That's where they intersect. So graphically it looks good. And then always remember that you should check your solution just to make sure that you are correct. So it would be easy again for me to just do a quick check. So in place of y, I would put in a negative 7, and in place of x, I would put in a negative 4. That becomes a negative 14, and on this side I have negative 12 minus 2. Negative 12 minus 2 is negative 14, and it checks in the first equation. In my second equation, I have negative 7 on the left in place of y, and then I will put in a negative 4 in place of x. So hopefully we have negative 7 equals negative 8 plus 1. And if we scroll down a little bit here, we will see that negative 7 does in fact equal negative 7. That one checks out as well. All right, let's move on to our last and final example. And this is a good example because it is not set up like you need yet. It is going to need to be revised. So one of our equations needs to be revised. We don't have any equation that has an x equals, and we don't have any equation that has a y equals. So you get to pick. And if I look at this top equation right here, x is pretty much by itself. There's nothing in front of it. All I would need to do would be to move this 2y over to the other side, and it would pretty much look like the other equations that we had in the past. So if I do that, I end up with x on the left side is equal to 9 minus 2y on the right side. And now I'm in a position where I can solve. Okay, so let's go ahead and rewrite that equation down here so we can see where we need to plug things in. So x is equal to 9 minus 2y. Well, now I know what x is, so if I put a box around what x is, I'm going to replace x in this equation with that box. So solving, I would get 3, replace the x with 9 minus 2y, plus 5y equals 20, and then I'm going to remember to distribute the 3 into the parentheses. 9 times 3 is 27. 3 times negative 2y is negative 6y. And then I would just need to combine terms on the same side. So I will combine the negative 6 plus 5 to give me negative y. Then I will go ahead and move over the negative 27 to combine it with the 20. So I'm left with a negative y is equal to negative 7. But remember, y is not isolated until it's positive, so I'm going to multiply through by a negative 1, so that would change that sign, and that would change that sign. So I know that 7 is my y coordinate, I just don't know my x quite yet. What I'm going to do then is take that 7 and I'm going to substitute it in for any of these equations in place of y. I could do it in the top one, I could do it in the bottom one, I could do it in my new one that I created, because really x equals 9 minus 2y is the first equation just rewritten differently. So I think I'm going to use this equation actually. So I'm going to keep this as x equals 9 minus 2 times 7. And I chose this equation because it's already solved for x. So it'll be less work for me in the end. 9 minus 14, and 9 minus 14 is going to be negative 5. So now I know that my x term is a negative 5. So negative 5, 7, if we go to our graphs again, just to double check. So I typed these in, and I should see something at negative 5, 7. And it looks like if I go over negative 5 to here, and I go up to 7, that is where they intersect. Graphically, it looks great. I would just want to check my solution. And I won't check my solution again because we've done a few already. But that's how you will work these. When you get to your Khan Academy practice, most of your practices will already be solved in terms of a variable, like your other 3 or 4 examples prior to this one. But you might end up with one like this. Just remember to take out your paper and solve for one of the variables before you practice your substitution. All right, and that concludes our lesson on substitution.